Okay, the next chapter we're learning here is about probability. And we're going to start by learning about the probability of simple events. So, probability is the chance that an event will occur. When people say it's like a 50-50 chance, right, that's a probability. An outcome is a possible result of any experiment. So when you flip a coin once, that's an experiment. When you roll a dice, that's one experiment. And a simple event is one outcome from one experiment. So when you flip that coin and it lands heads, that's a simple event, right? The outcome was heads. The experiment was you flipping the coin. And we'll answer questions like how many different outcomes are possible when randomly selecting, let's say, one of these M&Ms. Right? How many different outcomes are there, color-wise? Right? There are 6 different outcomes. Although there are more than 6 M&Ms there are only 6 different outcomes. Right? You can get an orange, a brown M&M, a yellow, a green, a red, or blue. Right? So there are 6 different outcomes you can get from this experiment of picking an M&M. Or what's the probability of selecting a green M&M? If I gave you this here and I had you randomly select one, what is the probability of selecting a green? Right? And that's what we're working on today. So to find the probability of any event, right here, the probability of an event, we will simply, to create a fraction, we'll put on top the number of favorable outcomes, so the outcomes that we're looking for, right? Favorable are the ones that we're looking for, like picking a green M&M. And we're going to put that over the total number of possible outcomes. Probability is represented by a number between 0 and 1. Okay? Numbers that are closer to a 0% chance obviously have a lower probability of occurring, whereas numbers that are closer to 1 have a higher chance of occurring. Okay? So we look at it here on this scale. Down here at 0, we call that being like impossible. Right? If it's 0% chance, that thing is impossible to happen. Right? What's the chance of rolling a 10 on a normal dice roll? Right? 0% chance to roll a 10. That fraction is 0. The decimal is 0.00, and the percentage is 0%. As we go up a little bit closer to 1, we have some things that are unlikely. Things that are between 0 and maybe 50%. Those things are unlikely. Right here in the middle is going to be a 1 out of 4 chance, or 0.25 probability, or a 25% chance of occurring. In the very middle, it's as likely to happen as not. The fraction for that is 1 out of 2, right? It's half. The probability is 0.5 as a decimal, or it's 50%. Right? Remember, to get the percentage, we take the decimal point and move it 2 spots to the right. Move it 2 spots to the right. So 50% chance to happen in the very middle. A little bit more than 50%, anything between 50% and 100% are things that are likely. There it's 3 out of 4, right? 75% chance of occurring. Or if we hit a 1 exactly, that's a 100% chance of happening. Those things are certain. What's the chance of rolling a number on a dice roll? 100% chance. So let's just do some examples here. What is the probability of rolling a 4, or P of 4? Probability of a 4. Remember that the probability of an event can be found by putting the number of favorable outcomes over the number of possible outcomes. So since we're looking for a 4, on this dice here, there's only one favorable outcome. It's landing on that 4. That's why there's a 1 on top here. Right, there's one favorable outcome, it's the 4. Out of how many possible outcomes are there? There are 6 sides on this dice, so there are 6 possible outcomes. So the probability then is 1 over 6 as a fraction. Or if I use my calculator and I divide 1 divided by 6, I get this as my decimal. And if I move the decimal point 2 spots to the right, I'll find that it's 16.7% chance to occur. So this is how I can write that probability, 1 over 6, or 0.167, or 16.7%. Okay, so try this one out. Again, we're looking for the number of favorable outcomes and putting it over the number of possible outcomes. And we're looking for even numbers this time on a dice roll. Okay, so how many favorable outcomes are there when I'm looking for an even? Well, I know on a dice roll I could roll, let's see, a 2, a 4, or a 6. Those are my favorable outcomes. Right? So there are 3 favorable outcomes. Three favorable outcomes. How many total possible outcomes are there? Well, again, we know that there are 6 different sides on the die roll, so it's a 3 out of 6 chance that we get an even. Or if I reduce it, 1 out of 2, right? And if I divide 1 divided by 2 to find the decimal, I'll find that that probability is 0.5. Or if I move the decimal point 2 spots to the right, I'll find that it's a 50% chance of occurring, right? There are 3 evens and 3 odds. 50% chance to get an even. Ooh, a spinner. What is the probability of landing the letter C on this spinner? Okay, so again, we're looking for how many favorable outcomes are there for spinning a C. I see on the spinner there's actually only one spot that has the C on it, right? And we're putting it over the total number of possible outcomes. So how many different possible landing spots are there for our arrow? It's 1, 2, 3, 4, 5, 6, 7. Looks like there are 8 possible locations for the spinner to land on. Only one of them is favorable for our C. So that's why the fraction then is 1 over 8. If I wanted the decimal version of that, I would do 1 divided by 8 on my calculator. I find that the decimal version of that is 0.125. Or if I move the decimal point 2 spots to the right, I find that there's a 12.5% chance of landing on the letter C. Not 0, not quite 50%, so that thing is unlikely to happen. Right? Not impossible, not 50-50, definitely not likely or certain, so it's going to be unlikely to happen. What is the probability of landing a vowel? So how many vowels do we have? How many favorable outcomes are there for a vowel? See, I see the letter A, that's one of them. So this is 1, 2. Okay, so we have 2 vowels. So there are 2 favorable outcomes for a vowel over the same, 8 possible outcomes? So if I reduce that, it'd be a 1 out of 4 chance of spinning a vowel. Or if I divided 1 divided by 4, I'd get 0.25 for my decimal. And if I moved the 2 spots to the right, I'd find that it's a 25% chance of occurring. Right? Better chances than just rolling a C, but still unlikely, as we are between 0 and 50%. Ooh, how could you word a question so that your probability of your event is 50% or 0.5? What could you be looking for to find a 50-50? That could be, let's see, we need then, I would need a 4 out of 8, right, for it to be 50-50. So what event would be a 4 out of 8 chances? I have 4 favorable outcomes. Maybe something like A, B, or C. And there are a lot of different answers to this. But if I have A, B, and C, I see 1, 2, 3, 4 favorable outcomes, right, out of a possible 8. So that would be a 50-50 proposition there, right? Anything where it's 4 out of 8. Okay, so moving on a little bit to complementary events. I know there's a lot of words here, but it's something that you guys can't handle. Complementary events are two events where either one or the other must happen. It's called being mutually exclusive there. So either this or this will happen. They cannot happen at the same time, right? When I do my experiment, they can't both happen. And the sum of their probabilities will equal 100%. It's a certainty that between these events, these two events, that thing will happen. Okay, and it's really as simple as adding the word not. So if I were to flip a coin, right, we can agree that you can't on one experiment land heads and a tails, right? They are not happening at the same time. You can't get a heads and a tails. But between heads and a tails, we can guarantee 100% of the outcomes. Right, so complementary events would be something like flipping a coin and asking for it to land on heads or not heads. Right, between heads and not heads, we can guarantee that's going to happen. It will be heads or not heads. I can guarantee that if you pull a card from a deck, right, between red or not red, we've handled every single possible outcome, either a red card or not a red card. Every outcome is accounted for there. 100% of the outcomes are accounted for between those two events, red or not red. Or from those deck of cards still, if I said diamonds or not diamonds, between pulling a diamond and pulling a not diamond, these are complementary events because between those two outcomes, right, I've covered 100% of all possible outcomes between diamonds or not diamonds. Right? If I were looking at complementary events from rolling a die, how about evens or not evens? Right? I've covered all the possible outcomes. It's either going to be an even or a not even. It'll be a 6 or a not 6. Right? I've covered all possible outcomes. Those are complementary events. Right? Where between those two events, I've covered 100% of possible outcomes. So how can we use that? How can we use complementary events? If I'm looking for the probability of something not occurring, I can simply find the probability that it will occur and subtract that from 1 or from 100%. For example, what's the probability of not rolling a 5? Well, if I'm looking for the probability of not rolling a 5, it'd be pretty simple to find the probability of rolling a 5, right? There's a 1 out of 6 chance that I roll a 5. Right? But the complement of rolling a 5 is what we're looking for. The probability of not 5. And it's quite simply, if I know that it's a 1 out of 6 chance that 5 does happen, I can take my 100% probability, my 6 out of 6, my 1, and I subtract away 1 over 6. Oh look, there's a 5 out of 6 chance that it's not a 5. Okay, or if I divided 1 divided by 6, I'd find it's 0.16 repeating, or a 16.7% chance of occurring. Right, and all of these are going to be complements here. Right, if I were to add 0.16 to, or repeating to 0.83 repeating, I get 1. We covered 100% of the outcomes. 16.7% chance or versus the 83.3% chance. These two added together form 100% of all outcomes. Right? 16% chance that it's a 5, 83% chance that it's not a 5. Again, these are two complementary occurrences, right? 5 or not 5. If 35% of students in a classroom are wearing a white shirt, what is the probability of randomly selecting a student who does not have a white shirt? I know that the probability of a student wearing a white shirt is 35%, because 35% of the students are wearing a white shirt. So the question is, what's the probability of picking a person who is not wearing a white shirt? Because these are complementary events, I know that this 35% plus my missing number here, my missing percentage should add to be 100%, which will be 65%. Right? Because 100 minus 35 is 65. So if 35% of the kids are wearing a white shirt, that means that not white shirt is 65%. Between these two things, that's all of the students.